Hi folks, we're going to take a look at page 29, number 17. So here they ask us to first determine what type of polynomial function each of the following is. All right, so we see here something a little different. Instead of having these polynomials in standard form, it looks like those polynomial expressions have been factored. Okay, so let's see if we can figure out what type of polynomial this is. So remember that in order to know the degree of the polynomial, we're only interested in the highest power of x. So let's think about what multiplication, so without actually having to do the full expansion, can we figure out what the highest power of x is going to be? Well, here I see that if I multiply these two binomials, the highest power of x I'm going to end up with is an x squared. Okay? Anything I multiply to the 5 is not going to have as high a degree as what I multiply to the 2x. So when I'm trying to determine the degree of a polynomial, I only have to look at the highest degree of each of the factors and multiply those. And we see that the highest power of x I'm going to get is when I multiply x times x, which is x squared, times 2x, which is going to be 2x cubed. Okay, so just by looking at the highest power in each of the factors, I can determine that this is a third degree polynomial. Okay, so if we take a look at the second one, well, again, here I have x plus 4 squared. That's going to be equal to x squared plus 8x plus 16. I'm only interested in the x squared portion, because when I then multiply that by x minus 1, it's only the two highest powers I'm interested in. So the highest power I get from the first factor is going to be x squared times the x is going to give me an x cubed. So yet again, we're going to have a third degree polynomial. Okay, and here when I see x plus 4 cubed, this is just x plus 4 times x plus 4 times x plus 4. So if I just take the highest power in each of those terms, x times x times x, yet again, I'm just going to end up with a third degree. Okay, so the fact that they're giving us these polynomials in this different form is implying that this is going to be important. All right, so hopefully you thought about what information factoring a quadratic gave you. All right, and in the next question, so they ask you to graph each function. Okay, and since they say to use technology, we use Desmos here. So I've got the three functions. So I look at the first and I see it definitely has a cubic form. I look at the second, again, it has a cubic form. And then I look at the third, again, it has a cubic form. So now they're asking us to find a relationship between this form of the polynomial and the x-intercepts, which hopefully is what you had thought about when you saw these polynomials in factored form. So again, remember, when you're looking for the x-intercepts, you're setting y to 0 here. So here I have three things that multiply to 0. So we're going to make the same argument that we made back with quadratics. If three things multiply to 0, then one of them must be equal to 0. So negative 4 makes this 0. 1 makes the second expression 0. And negative 5 over 2 makes the third expression 0. And when we graph the function, we see indeed that we've got negative 4, okay, negative 2.5, which is negative 5 over 2, and 1. All right, exactly what we expected based on what we saw. Now, when I look at the second equation, well, I see that there's only two different factors. So negative 4 is going to make this equal to 0, and 1 is going to make this equal to 0. And so what do we have? Negative 4 and 1, our x-intercepts relate to this factored form. Okay, and if I look at the third one, I should expect that the only thing that's going to make this equal to 0 is negative 4. And of course, when we graph it, we see that the only x-intercept is at negative 4. Now, you may have already noticed by now that there's a little more to this story, which I'm going to let you think about, and we're going to take up in class. Okay, that maybe there's something more we can say about these x-intercepts beyond identifying just what they are. Okay, but I'm hopeful that we're not too surprised that looking at the characteristic for x-intercepts is going to involve looking at these functions in factored form. Okay, that's it for this one.